Let's find the radius of convergence for the following power series. We have the sum from n equals 1 to infinity, 4x to the n power over n squared. So for this we have to use the ratio test. So we're going to add one more to n. And then we're going to divide that by the original, a sub n. And we're going to take the limit of this thing as n approaches infinity. And we want this to be less than 1 in order for it to converge. Okay, so we're going to rewrite this. First, we're going to multiply the top and the bottom like that. So it's 4x to the n plus 1 times n squared. And that's going to be all over these two middle ones multiplied. And I want to line it up exactly. So I can either have n plus 1 squared times 4x to the n, or 4x to the n times n plus 1 squared. So I'm going to choose to do 4x to the n times n plus 1 squared, since this is going to line up nicely. The nice thing is I can simplify 4x to the n plus 1 and 4x to the n. There's only going to be 4x left, and I can factor that out since it does not depend on n. And so I have the limit as n approaches infinity, absolute value of n squared over n plus 1 squared. And we want this thing to be less than 1. Now, this limit is going to be 1, since in the long run, this is basically n squared over n squared, which is 1. So what I'm left with is the absolute value of 4x is less than 1. And so the absolute value of x will have to be less than 1/4. So because I divided both sides by 4. So the radius of convergence here is 1/4. Next example, we have the sum from n equals 0 to infinity, x to the 2n over 2n factorial. We want to find the radius of convergence, so we're going to use a ratio test. We want to find a sub n plus 1. So we're going to replace n with n plus 1. So you have to be very careful, especially for the factorial, because that all happens inside before you take the factorial. And we're going to divide that by the original. And we want this limit as n approaches infinity to be less than 1 in order for it to converge. Okay, so I'm going to distribute out the 2 here. That's going to be 2n plus 2. That's x. And I'm going to multiply that by 2n factorial. That's going to be over these two multiplied. So I'm going to choose to do x to the 2n first to line it up. And then I have to distribute this 2. So that's going to be 2n plus 2 factorial. And then we have the limit as n approaches infinity. And we want this to be less than 1. Now, the only difference between x to the 2n plus 2 and x to the 2n is a factor of 2 in the exponent. So this will cancel out and you'll have x squared left. And we can pull this out in front with the absolute value. So we have the limit as n approaches infinity. Now we can simplify 2n factorial over 2n plus 2 factorial as just 2n plus 2 times 2n plus 1. So all that's left is 1 over 2n plus 2 times 2n plus 1. We want this to be less than 1. This limit right here is going to be 0 because it's basically 1 over n squared. So we'll have 0 is less than 1, which is always true. So what this means is no matter what x is, we're always guaranteed that this is always less than 1. So the radius of convergence here is infinity.